You may have noticed in my last video that my workbench looked a little bit different. Over the summer I got tired of limited storage on my back wall, and I wanted to do something custom. What came out of that idea was a new pegboard wall, made mostly of materials available at any home center. This now has space for all my electronics gear, various tools, and the bulk of my photography and videography gear. Yes, pegboard isn't everyone's first choice, but I love it, and I'm really excited to share the build process with you today on John Builds Things. We start in my garage workshop where I laid out a basic 8-foot by 2-foot frame with a few planks of wood spaced out vertically across it for a fastening surface for the pegboard, and I squared it up by tacking some plywood scraps in the corners. After that I put down the pegboard with glue and screws. By leaving the frame a little short on all sides, I was able to have an overhang that I trimmed back with my router for a nice flush finish on all sides. I went with just regular home center pegboard because I wanted a custom size, and all the metal or composite pegboard products online came in odd sizes that didn't fit my needs. They were also way more expensive than what I paid for these two panels of pegboard. On the top I also attached a 1x3 to create an overhang for a strip of bright white LEDs. After painting I went back and attached those on top. Off camera I came in with some clear epoxy and dabbed it on key spots to make sure the lights never came off. I ran the wiring down and through the panel for later hookup. I needed to remove the old cheap plastic pegboard panels I got on Amazon like 3 years ago. My son happily took those to play with. To the wall I also attached a large piece of wood to use later for my monitor mount. With the surface and wall clear, I brought in the new panel and used some wood blocks to get the spacing off my desk just right. Finding the studs on this exterior wall was a little interesting, but after you find one, the rest is pretty easy. It wouldn't have been a project without some 3D printing. In this case, there are plenty of pegboard models online. However, you have to be careful when looking at the type of pegboard they are for. Generally in the US, pegboard means 1/4-inch holes spaced out 1 inch apart. And there are several variants, like the IKEA SCADA system, which looks cool, but again, pushes the price point out to a place I didn't want to go to. Additionally, with that system, it's impossible to just walk into a hardware store and buy a bunch of hooks to work with it. That's one of the many reasons why I stuck with standard pegboard. So anyway, I printed some 1/4-inch and 4mm hex bit holders that sit on these cool Gridfinity pegboard shelves, a wire spool caddy, tweezer holders, and various parametric bits. I've linked to all of those, so definitely check it out. To lay everything out, I started on the right and tried to place my most commonly used tools like my screwdrivers and bits, soldering iron, wire cutters, multimeter, etc. in a pattern around the monitor. All the way on the left, I also eventually built up a section of photography and videography equipment. Those are things that don't need to be at arm's reach from my workstation on the right, but need to be easily accessed when I'm on the move. These are things like tripods, mounts, etc. The middle is somewhat of a no man's land of less used things, like specialty cables and tools. Honestly, I'm still working that out. The LED strips along the top provide a ton of light, but shining right out would look weird from my main desk and be pretty glary when at my workbench. So I modeled and printed these light covers that slipped right over the 1x3 at the top. They fit with a nice friction grab, but I still used a little glue to make sure they stay put. For the seams, I printed some nice clips that give the entire thing this nice pattern. For the electronics, it was a little complicated but manageable. So I wanted easy integration with my Home Assistant install. I'm really into integrating everything on there, and it's an amazing platform. To do this, it was easy as writing a YAML configuration and loading it onto an ESP32 with ESPHome. I love this tool. You just describe inputs, outputs, and connectivity, and it handles everything. It's a very powerful platform, easy to work with, and better yet, it's a really strong case for vibe coding. Now I'm a software engineer by day, so I have no illusions about what generative AI can and can't do. It has its limits for sure, but writing highly documented configuration files, this is a perfect use case. The ESPHome configuration validator is strong, so I picked up some misconfigs quickly that I was able to resolve by chatting with ChatGPT. The ESP switches on the lights indirectly by toggling a MOSFET on and off, and it uses a motion sensor to turn the lights on when there is motion. It also auto shuts off the lights after 15 minutes of inactivity from the motion sensor. All of this was easily defined just using that YAML configuration. Additionally, it's easy to understand what the board is doing thanks to the optional web interface you can enable in configuration as well. In addition to the ESP32, I also have an old Raspberry Pi as part of this setup. The reason for that is I wanted to display text on this old LED matrix sign. It's like 20 years old, and the software used to program it is pretty limited compared to what the sign can do. And so I was able to go through the sign's serial interface specification, and again with some vibe coding, write a Go library that will live update the sign's display over serial connection. Because I want to update the sign based on an output of a few different APIs, this was too heavy of a task for an ESP32, so a Pi did the trick. A Pi 0 would have been fine, but I didn't want to hassle with digging out the right USB adapters and such. The more complicated part of this electronic setup were the power requirements. The ESP32 and the Pi both run off of 5 volts. The sign needed, oddly, 7.5 volts, and the lights needed 12 volts. I handled this by starting with a 12 volt supply, and using 2 DC to DC converter boards to bring that 12 volts down to the right level. To contain the electronics, I was going to mount all the PCBs underneath the countertop, but I wanted easy access in case I needed to reflash a board or make adjustments later. So to do this, I designed a simple chassis in Fusion to screw all the boards onto, and I printed a parametric latching box to contain it all. These parametric boxes, which I've linked to in the description, can be tailored exactly to your needs in terms of width, height, and depth. And there are a few options with how the hinges and latching hardware attach. The most basic configuration, which I've used here, uses 2 long M3 screws for nice reliable hinges, and the latch just clips in. I definitely recommend these for any use where you need a quick solution for a rugged, customizable project housing. I picked a spot off to the left of the pegboard that was out of the way for the housing. Everything is wired in via some conduit, and I've got a simple 12 volt wall adapter for power. To secure the housing to the wall, I just used a single drywall anchor, since it's not a lot of weight and stress on it. With everything loaded up on the wall, it is barely noticeable, and having it somewhat accessible again makes servicing it easy, and I can quickly power the whole thing down when I'm on the road. Here's the final build. What I love the most about Pegboard is just how easily it is to modify. I expect this panel is going to go through several evolutions and phases as I tune it to my needs as I use it. Thanks again for watching. Please like the video and subscribe to John Builds Things.